Okay, we're going to continue with our transcendental functions, and we're going to look at the exponential function today. And it is actually one of the easiest derivatives and integrals to work with. In fact, it's actually quite interesting. The exponential function e to the x. We can see here the derivative of e to the x is e to the x. Its rate of change is itself. That's just kind of cool. The derivative of e to the x, or e to the u, some kind of function, will again be e to the u, so you just rewrite it and then multiply by the chain rule. So we practiced that a few times here. We see that this is just a constant multiplier, so this is the derivative of 5 e to the x will be 5 times derivative of e to the x is e to the x. So it's just 5 e to the x. Easy peasy. Here, this next example, the derivative of e to the negative x, it's going to be e to the negative x. We just repeat it, and then we multiply by the chain rule. The derivative of negative x is negative 1, and that is the chain rule. Once again, the chain rule. There is a typo. That's supposed to be sine x. The derivative of e to the sine x, we rewrite. So e to the sine x times the chain rule. The derivative of sine x is cosine x. So again, chain this into that. And those are those examples. That's how easy the derivative of e to the x is. Next page, we're going to get into the integral. So we're just going to be going backwards. We have the integral of e to the u du equals e to the u plus c. So remember that most of the time you're going to have to do u substitution. And now not only is it inside things or the denominator, if it might fit the natural log pattern, but it can also be the exponent on the e to the u pattern there. So if we look at this definite integral from 0 to natural log of 2 of e to the 3x, it's clear that u is going to be 3x. So then du is 3dx. Well, we don't have 3dx. We only have dx. So we need to multiply by 3 on the inside and 1/3 on the outside. So 3dx becomes our du. 3x is our u. So we do a quick little substitution here. And we get u, because that's, just kidding, that's e to the u, du. So we have e to our u. 3dx becomes du. We plug in our numbers here. This x value of 0, plug that in for x. We get 3 times 0 is 0, so u is also 0. Natural log of 2, plug that in, and we get 3 times the natural log of 2. Well, that's not very pretty, but we can work with that. Now we're going to integrate. Well, the integral of e to the u is e to the u. Easy enough. If we can write it all. Plug it in, we get 1/3 e to the 3 times natural log of 2 minus e to the 0. Anything to the 0 power is just 1, so we have 1/3 e to the 3 times natural log of 2 minus 1. Now, we can use that. We'd want to cancel this, but we can only cancel that if they're touching. Well, we can make them touch if we pull that up top. So we have 1/3 e to the natural log of 2 to the 3rd minus 1. Now, e to the natural log, now those inverses cancel each other out. And we're left with 1/3 2 to the 3rd, which is 8, minus 1. 2 to the 3rd equals 8. So our answer is just 7/3. Our next example is straightforward as well. We have u equaling the power right there, which is sine x. Our du is cosine x dx. So we have du here, we have u here, our integral becomes e to the u du. Sine of 0 is 0. Sine of pi over 2 is 1. We integrate and we get e to the u. Evaluate it from 0 to 1. Make sure that you show that integral process, that you show this step, because you must actually integrate. Even though it's the exact same thing, you still have to integrate. Then we're going to substitute, and we get e to the first minus e to the 0, which simplifies to e minus 1. So here's an initial value problem involving e, the exponential function. First thing we're going to do is separate our variables. We have e to the y dy equals 2x dx. We're going to integrate both sides. Integral of e to the y is e to the y. Integral of 2x is x squared. We only need 1 plus c, remember when we do these. Now we need to solve for c. We can solve for y and then solve for c, or we can solve for c right here. I would go ahead and solve for c right here. So we have, remember this means that x equals 2, or when x is 2, y is 0. So we have e to the 0 equals 2 squared plus c. 1 equals 4 plus c. So c is negative 3. But that's not our answer. We need y equals. So starting back again, we have e to the y equals x squared. C is negative 3, so that's minus 3. Solving for y, we take the natural log of both sides. We get y equals the natural log of x squared minus 3, which is what we're done with. Now, some people might be asking, what does this have to do with anything? Well, remember, this has to be positive. So x squared minus 3 has to be positive. So x minus square root of 3 and x plus square root of 3 have to be positive. Well, that gives us zeros at negative root 3 and root 3. We're positive on the outsides, negative on the inside. And we need natural logs to be positive. So we need this section or this section. We chose just the section to the far right.